Hi, today we're going to be talking about forces. And forces happen a lot in real life. If you take physics, you'll learn a lot more about them. But for instance, an example of forces in real life would be if you were pulling your luggage that doesn't have wheels across the floor. You'd be pulling against you'd be pulling the luggage, which would cause one force, but then friction would cause a second force acting against your pull. And then you would get something called a resultant, what actually results from the friction and you pulling. This is kind of like that idea. Example number 1, two forces of 25 and 15 pounds act on a body. All right, basically that means that there is an object here. And one force is pulling 25 pounds in one direction and 15 pounds either with you or against you. But in these problems, it's just going to be kind of like this. Now, you're just drawing a picture to visualize it. It may be an obtuse angle there. The key is that you just get an idea of what's happening. So there's one 15-pound force and one 25-pound force, and it's basically acting on a body, and this is the body. Okay, so what happens is this person, the red one is pulling this way, the blue one's pulling in a different way, and what's going to happen is that this object is going to move based on those two pulls. Now, since the 25-pound force is bigger than the 15-pound force, then it should make sense that the object is going to move in the middle area, but not directly in the middle because the 25-pound force is bigger. So that's what's called the resultant, and it's really important that you know where all the pieces go. The resultant is where the object goes, somewhere between the two forces, and there's force 1 and force 2. Okay, so what's happening now is that the red force is acting on the blue force. So I'm going to do this a dotted line because this force exists. It's just acting on that blue one. And at the same time, the red force has the blue force acting on it. So now the blue one is going to act on it like that. And what happens is it creates a parallelogram. Now there's one other piece of information that they do tell you. They tell you that the angle between the two forces, and let's see, I'll use green. The angle between the two forces is 75. Now this is the one problem that a lot of students don't know, like where that goes. But that's why I purposely use solid lines and dotted lines. The original two forces are those two solid blue and red lines. So when we say the angle between them, we mean the two original ones. So 15 all the way to 25, that angle is 75. Okay, the only, so 75 is the angle, and what happens now is we have to somehow figure out what the magnitude of the resultant is. And the magnitude of the resultant means how long is the resulting thing going to move. All right, a common misconception is students want to take the 75-degree angle and split it in half. But that's not true, because in order for the angle to be split in half, the two forces would have to be identical for the object to go straight down the middle and to bisect that angle. So it's definitely not going to be split in half. Now, if you notice, we created a parallelogram when we put all the forces and acting forces in the diagram. So what you have to do now is understand the properties of a parallelogram, which I have in this bottom box down here. Opposite sides of a parallelogram are equal. Okay. And then opposite angles are congruent, so I'm not going to do that, but this whole corner right here would be 75 as well, but that's not going to help me, so I'm going to get rid of it. The other rule that is going to be helpful is getting the other angle up here. In a parallelogram, this angle, this whole angle, and that whole angle are supplementary. That means they add up to 180. So 180 minus 75 is 105. All right, now this picture is getting really congested now. If you notice, we have two triangles we're working with. And I didn't really draw it to scale, but they're really two congruent triangles, even though it doesn't look like it in my diagram. But we know from the previous few days that we have law of cosines and law of sines that I can use to find angles and sides that I'm missing. But I have to work with a single triangle. So here's a triangle. I color-coded it yellow. It might be helpful for some of you to actually redraw that yellow triangle out and put that yellow triangle here. So let me clone it. So for some of you guys, it might be better off to redraw that triangle out. That way you can see what's happening. So let's see. That yellow triangle has a 15 side. It has a top side of 25. And it has this top angle of 105. And we're trying to find this X side, which is this one. By taking it out of the picture now, it's really clear that in order to find out the length of that resultant, we would do the law of cosines. All right, so that's it. The hardest part is to know is to draw the diagram, because if you don't set up the diagram correctly, obviously you're gonna have a difficult time in solving it. So put all your pieces on properly, your two forces, your angle between, locate any other information that might be useful, and then if I were you, redraw out the triangle. It's gonna be clear now to use law of cosines, and all we're gonna do now is solve like we normally have. So we're gonna get our calculator. Okay, since X is by itself, we're just going to go ahead and type in the one whole right side into our, into our calculator. All right, so we get X squared equals 1044.114284. And then to get rid of the square, you do square root. And you get X equals 32, let's see, we have to round to the nearest pound. So 32 pounds. All right, let's try two more problems. See them again. The main part would be to set up your diagram correctly. All right, problem number 2, when forces of 12 pounds and 8 pounds act on a body. All right, so here's the body. Could be a car, a luggage, something. Okay, I usually like to put the longer force on the bottom, but it doesn't matter. So this is the 12-pound force, and then this is the 8-pound force. So again, the resultant is obviously going to go somewhere in between, but closer to the 12 side because that's pulling harder. All right, and in the end, you have the 8-pound force acting on the 12-pound force, and you have the 12-pound force acting on the 8-pound force. All right, the question, and they even told you in this problem that the magnitude of the resultant is 15. So this time we have that side. All right, well, I have absolutely no angles, but I can figure out the other sides of the picture. This other blue side is 8. And this one's 12. Okay, the question wants to know, find to the nearest degree the measure of the angle between the two forces. Now remember, between the two forces is always those original two solid forces. So our goal is to find that whole big angle. Now, if you can see, that angle is made up of two smaller angles. So that's not the corner angle of either triangle. It's the corner angle of the parallelogram. All right, so if I highlight, let me see my triangle, because we're definitely working with triangles. So there's my triangle. All right, I'm going to clone that. So here's my triangle that I'm working with. And what do I know about it? I know all three sides. So somehow I have to get to that X angle, but I can only work with that yellow triangle. All right, now there's two ways to do this. The long way would be to find the little angle here, which is here, and then find this angle here, which is actually congruent to that angle there, and then add up the two little mini angles. What's easier is if you find this angle right here, because we know that that angle y and that angle x are supplementary. So that would be a quicker way to answer the problem. But the other way I told you about would also work, just be a little bit longer. Okay, so how can I find angle y? Again, I have the group of 3. So I can do law of cosines. Okay, odd guy out squared equals the other two sides added and squared minus 2 times 8 times 12 cosine of the angle y. All right, so this one's a little bit more difficult because I cannot add up all those numbers together. So 225, 64 plus 144, and then you can multiply those 3 together, which I believe makes 192, but I will double check. Okay, so negative 192 cosine of y. All right, so we can add those two together because those are like. All right, should be 208. Let's see, 208. And again, cannot add up those two numbers because that number has a cosine with it. So we're going to subtract over 208. All right, I need to extend the page. Okay, 17. Right, don't lose that negative sign right there. And then divide over negative 192. And cosine of y equals that. And if I want to find the angle, we do cosine inverse of that. Leave the negative on because I want the quadrant 2 angle. That's the obtuse angle. Okay, so I know that angle y is 95 degrees. But remember, that wasn't really my answer. That's just this corner angle right here. That corner angle is 95 degrees. If I want to get to the x angle, I can now use the fact that a parallelogram, those two angles are supplementary. So basically, angle x equals 180 minus that 95 degree angle corner, and angle x is 85 degrees. Again, just a matter of knowing what pieces you have in the diagram. Maybe redrawing the triangle will help, and it's not always going to be a one-step problem. All right, we'll try one last problem. So two forces act on a body at an angle of 72. All right, so we have force 1. Here's my object. Force 2. And it acts on a body at a 72 degree angle. So that's the two forces. So that's this one right here. So that's 72. We know our resultant is going to go somewhere like this way. And then we also know we're going to have these acting bodies on it. So if you hear it's a forces problem, you pretty much know it's a parallelogram problem. All right, so it says that the two forces act on a body at a 72 degree angle, resulting in a force whose magnitude is 110. So it's resulting in a force whose magnitude is 110. So that means that the resulting force is 110. They usually call it the resultant, but they said it that way, that's fine. If the magnitude of one of the original forces is 80 pounds, find the magnitude of the other force to the nearest pound. Now, I have no idea which one is the 80. It really doesn't matter. I'll just put it here, but it could have been the other one. So basically, I need to find what this is. Okay, so again, I want to really focus on one triangle right there. Okay, so I'm going to redraw that out. And let me start naming things I know about it. Okay, this side is x, this side is 80, and this side is 110. All right, what else do I know about it? Well, I know that if this corner angle is 72, I know that this angle right here has to be 108 because those two make 180 degrees. So that's 108 degrees. Okay, so now that's it. I have absolutely no other thing I can figure out. So can I get to x right away? Well, I can't do the group of 3 law of cosines because with law of cosines, I can only have an x there or there. So that would be impossible to use. So I am forced to do law of sines. No choice. Law of sines, well, I have the angle side buddy right there. Now, if I want to get to x, I would have to actually have that angle, which I don't. So that's lacking too little bit. So I am forced now to go and find a piece that I didn't necessarily get asked about. I need to go this way. And I'm forced to find this angle. I'll call that y. All right, so it's going to be side 80 over sine y equals side of 110 over the sine of 108. All right, cross multiply and divide. Okay, so it means that that side is, or I'm sorry, the sine of that, oh, I apologize, it was 110. Okay, because the sine can't be over 1, so I knew I made a mistake. So here the sine value is 0.6916774 dot dot dot, and to find the angle, I do sine inverse. All right, so that angle is 44 degrees. Now remember, there is a second answer. It also could be 136, but it won't work because 108 is already too big. So I don't need to consider the second option. So 44 then is angle y. And now to get to x, I need to find the other angle. So 108 and 44 degrees add up to 152. So this angle right there has to be 28 degrees to make 180 for a triangle. Now, once I have that angle, now I can actually use whatever I want. I can use law of sines or I can use law of cosines because I have a lot of information now. Sorry, I'm trying to get rid of this. I have a lot of information now that I can use to find the x side. I can use law of cosines or I can use law of sines. So it's up to you which one you like. I don't know. I like to find the side by law of cosines because all it is plug it all in and square root it. But if you like the law of sines to do proportions and cross multiply and divide, you can definitely do that. Either way is going to work. So let's see. We're going to have x squared equaling the group of 3, 80 squared plus 110 squared minus 2 times 80 times 110 cosine of 28. All right, so now 2 steps. 80 squared plus 110 squared minus 2 times each of those. And then square rooting it. So I get that that side is 54 pounds for the force. And that's what I needed, so now I'm done. All right, so just make sure that you take your time with the diagram, because if you get that messed up, it's obviously going to mess up the rest of your problem.